Mhm. Hello guys, so welcome back to another live video. And so for today, we are going to talk about which is better to fix. Is it the live circuit or the dead circuit? So there are some advantage or disadvantage when it comes to uh, fixing this two situation that you will be having. And so for me, the best condition on the control panel to troubleshoot is if it is a live circuit. So for me, it is easy for me to analyze the flow of the current and where and when it will have a closed loop onto our circuit, right? So there are some which they prefer to switch off the whole control panel and then they will check the components one by one. But for me, I'd like to do it in a different way. And I think this is also the same practice that others are also doing. And I hope you will you will give a comment on which is your or what is your preferred status when it comes to fixing or troubleshooting certain machinery. Is it a live circuit or a dead circuit, and why? Why you choose that or you chose that uh, kind of condition? No? So for me, I like to fix uh, a certain trouble when it is a live circuit. In this way, I can just put one of my probe into the closing loop, and then I can put the other probe, whether it would be whether I am measuring AC or a DC voltage, or even the resistance or the continuity of our system. Excuse me, I'm drinking coffee right at the moment, and I haven't yet fixed my studio, which I'm planning to do almost every or a daily live, so that we can talk about the things that we normally do on board and what are the tips and the actual techniques that I am using, so that it can make my life easier during troubleshooting. So, good morning, Sir Larry Watkins from Graham, Washington. Hello, sir. Good evening, and I hope you will enjoy your weekends and your holidays. So I prefer to fix the circuit in a live condition. So let's say now, if you're having a single phasing on one of the system, and let's say you suspect single phasing onto the F1. So in the F1, the easiest way is I don't need to just like drop off the main supply like from the L1, L2, L3, and then I will try to push the F1 and then measure the continuity of each line, right? That would be the condition when you're testing it as a dead circuit. But in a live circuit, it's just too easy, right? I'll just measure, let's say it is a 440 volts AC. So, I'm sorry. So, if it is a 440 volts AC, then for sure, you'll just measure on to each phase. Let's say from line 1, so you have your multimeter, right? Set it on AC volts, no? So you'll just measure line 1 and line 2. So you'll have 440 volts. Then I'll just move the other probe onto line 3. right? And then I should have 440 volts. And then I'll just move the other line onto the line 2, and then I should have 440 volts. In this way, you'll have a present 3-phase onto your system. Now, I need to check if I am having single phasing onto the F1. So the best way is to leave one of the probe, number 1, and then you have to put the second probe onto the number 4 on the line 2. You should be measuring 440 volts also onto your multimeter. Because if F1 is closed, no? So if F1 is closed, assuming it is activated, so closed. So you'll have a continuity onto the whole line. So it's just like measuring line to line voltage. So in this way, um, it would be very easy for you to just move again the probe. Let's say line 1, you move it to the I'll just clear this one a little bit. So the next probe will be onto the line 3. I should be having 440 volts also. And then I'll move the first onto the number 3. I should be having 440 volts. So if this technique that you're doing is you'll have all 440 volts onto the system, that only means that you're not having a single phasing. So all the phases and all the contacts from your F1 is in good condition. But if there will be a missing phase, or there is a single phasing, so this will be the analysis. No? So if I will measure onto the line 1 and line 2 across, and I do not have 440. Okay, I do not have 440. Let's say it's just 220 volts. So it only means that one of them is not working. So which one is not working? So for sure, if you measured initially on top that you're having 440 volts, then your line 2 contacts is busted. And that is why you don't have 440 volts from this line. Okay, input line and output of line 2. You don't have 440, it's just 220 volts. Then you're having single phasing onto the midline. So for me, it's easier to analyze and to troubleshoot if the circuit is a live circuit. Same goes to the fuses, right? So let's say you have fuses. You have fuse. Okay, you have sometimes different fuses with modular fuses, right? I'm sorry for my drawing. So then you'll have your fuses inside, right? You'll have your fuses inside. So you will know which one is busted by just measuring your input and output voltage. Let's say both of these are just 220 volts. Now this is L and N, L and N, and then this would be your output now. So if I will measure, if I want to know if there is a busted fuse, I'll measure line and neutral onto the first line, these two pair, so for sure they are paired, then the L and N, so I should be having 220 for the both, no? So if I will check which one is busted, if I will leave my probe here and move it onto the N, I'm having 220, then the next one, so I'll change the color so that I'll repeat it again. So if I will put my probe into the first point, and then the second probe of my multimeter would be onto the output line of the neutral, then I have 220 volts, then this fuse is okay. I hope you get it now. For this is especially for the beginners. Then if I will put my probe onto the neutral line and put the other probe onto the output of the L, no? And I'm not having 220, it's just 100 volts, then I am having a busted fuse. So this would be the busted fuse. Because you assume that this, if this is good in healthy condition, you should be having 220 volts also. So this is busted. As simple as that. So for me, I don't need to switch off the panel, retract, remove all the fuses one by one, hold it in my hand, and then I'll turn the knob of my multimeter to resistance, and then while I'm holding them, I'm measuring them one by one, the continuity, and if it will sound or not. So for me, it's too hassle, no? So that's why I preferred to fix certain trouble in a live condition. So if there is a supply voltage, if it is a live circuit. So excellent, India. Good night, sir. So good night to you, sir. Nitin Sharma. Hello, sir. Good evening. Atula Kumara. Good evening. Mehmet Yasar Soy. Very good drawing. Thank you very much, sir. And I hope I'm pronouncing all your name in a correct way. So if I'm suspecting that there is one um, contacts which is missing, then this procedure also applies to the contactors, right? Of course, if there is a single facing, you will know that there are some conditions. These are the disadvantage. No? There are conditions which, if it is a single facing, or you're just suspecting that there is a single facing, because initially the condition of your of your of your circuit would be like, let's say we will run it. Okay, this is the condition. I run the switch 1 forward operation, and then my F2 tripped. Okay, so while it is tripped, so this would be the alarm and this would be the condition. So as you can see, in this situation, you have an open OCR, right? The abnormal alarm is lit, the system is stopped, source is on. So it only means that you're having an overloading onto your system, short circuit, or a single facing. This could be the possible situation because your overload relay is activated. No. Jasbinder Singh, hello sir, good evening. Please speak my name also. Hello sir. Jasbinder Singh, good evening. Where are you from, sir? Mehmet Yasaroy, yeah, correct. Thank you very much, sir. And thank you for watching. I hope you will share our live today so that we can still share and spread our knowledge, and we can spread our free education to other also, no? So in this condition, if I want to test the circuit in a live condition, of course, there are limitations. You cannot, if there's an alarm of overloading, no? There's an alarm of overloading or causing the circuit to overload. It's overloading, if this F2 is activated, right? So there will be a high current, right? Amperage onto your system. But you want to try which contact is having a problem, right? So the best way is to try to reset the system, but you have to investigate after by not starting the control panel. Okay, best way is to check first the condition of your electrical motor. No, if it is hot, if it smells burn, no, check the terminals if they are all intact and all the lugs are in good conditions, right? Do an insulation resistance test. So continuity test, and then do a line to ground test on the electrical motor so that you will know. No? If you can rotate the electrical motor by hand and it's a freewheeling, you will know that it's not having a mechanical failure, right? Sometimes if your bearing is stuck, then you'll have your motor will be overheating. No, you will have a high current and it will overload, activate your F2. So this would be the first thing that you need to do before you can do a test onto your circuit, right? So if you check all these conditions and the motor is not hot, it means it didn't run in a much effort way. No? So there would be a prolonged running why just before it overload, because sometimes if you have a faulty electronic equipment like your F2 itself has the problem, then this will also activate, or it will trigger the alarm even you don't have overloading onto your system. Don't rule out that possibility, because there are instances that is also happening wherein I need to change also the overload relay. I think because it is also always being used, right? Every time your main contactor is running, right? So this F2 will also be a possible cause why you're having an overload alarm. The overload relay itself is the problem. So if you check it is not hot, it doesn't smell burn, your what do you call this? Your terminals are intact. You did a continuity test that all the windings are okay. And then line to ground is healthy. You don't have earth fault. You try to run by hand and then it's rotating. It means the bearings are in good condition. So there is no way that the system will overload unless there is a single facing onto the system or onto your contacts, right? So considering the condition, because if you will find already abnormality onto your electrical motor, then that's it. Our discussion will already be finished. Then my only advice is just to overhaul the electrical motor, or if you have a burned wires or windings, then you just need to replace the electrical motor, right? As simple as that. Discussion finished, right? So let's say it's overloading, and then that would be the condition. Now, single facing might be happening also onto your contactors, right? But of course, the limitation of testing a live circuit will happen here. You cannot test a contactor if it is a single facing in a high load or at any circuit that could compromise the safety of the technicians and your machineries. So the best way to check if the main contactor is giving a single phasing is to switch off the main breaker and try to activate it manually by pushing the magnetic contactor. So by pushing, you have to stop the operation, and then that's the time you need to do a manual activation, pushing it, and then again apply the same. No, since it is a, I'm sorry, since it is a dead circuit, try to push it and then just do a continuity. So turn your multimeter into resistance, uh, in, and then do a continuity test onto the line to line. There should be a close contact. No, there should be a continuity. Check all the lines, the resistance, the continuity, if they are in good condition while you are pressing or activating the main contactor manually. Let's say in a certain condition wherein you do not have a forward operation, because this circuit is an electrical circuit diagram wherein it operates in, okay, let's reset F2. Let's try to run S2. Now it's in reverse direction, right? Electrical motor is running in reverse direction. I'll stop it. I'll start S1, and now it's running in forward direction. And I'll stop it. Let's say your forward operation, the electrical motor did not run. So you're having problem with your forward operation. So what would be the first step that you need to do? So this, I'd love to do it by just clamping one of the probe into the common circuit, and that would be, or the common point, and that would be the A2 of your magnetic contactor, the coil, no? So I'll use my multimeter again. So let's use different color. I'm going to use so since it is a live circuit, I'll use again in voltage, turn it into AC. So this is as a safety precaution, right? The best way to check your your panel is, regardless if you know the output voltage or the voltage of that system, even you are sure it is 24 volts, you still need to use an AC. You need to put your selector onto the AC of your multimeter and try to measure if it is in AC or DC. Double check or triple check your system first, unless you are the one who did the control panel itself, because you'll never know, maybe it's also an AC or there is a problem onto the system and it's still an alternating current onto your system, no? So you'll need to measure both lines if it is in AC. That's why initially you need to turn your knob into AC, and then if you are sure that it's not AC, that's the time you put it in DC operation. So DC, no? And then I'll connect my positive probe into positive, which would be the A2. Right? I'll just clamp it there. Since the circuit is live, no, I'm just not having the forward operation, right? So then I'll just put my other probe onto the output negative line of my power supply. For sure, let's say it's DC, so for sure you'll have, let's say, 24 volts across these two lines because it's just a closing loop, you know. So there will be no voltage drop onto the system. Rogelio Tampepe, good evening, sir, watching on board. Thank you very much, sir, Rogelio. Shiva Durga Vlogs, good evening, sir. I'm from India, Andhra Pradesh, sir, Shiva. Mehmet Yasarsoy Bering. Okay. Dari Watkins, do you check the logs when the system is live? We drop the whenever we will touch, for sure we will drop the circuit breaker and we'll use lockout tag out. Of course, it's a visual check, right? So you don't need unless you did the live test onto the system. The live test that I'm saying is that which one is much easier to do on each point, on each node, no. But if it is onto the terminals itself, and which involves also touching with your hands whatever circuit it would be, and then for sure you need to drop off the breaker. But if only checking points like your line to line, and you want to know where would be the flow of the current was cut, and then it is much better for me to test the circuit in a live condition. For me, it's much easier and faster, no? Tim Anton, yes. European symbols. Thank you so much, Jackie from Turkey. Thank you, Fatih. Santu Purkait, I am on board. Which vessel you are in? Santu Purkait and Sadike Mustafa. Hello, sir. Sadike from India. Thank you very much for watching. So here, you'll have 24 volts. Then the next one would be as simple as this. And then I just need to move it onto the 96 probe. I should be having 24 volts. No. And then I need to move it onto the next. I should be having 24 volts. Otherwise, not having. And then there will be no way that this OCR is the problem, this contact, if you're not only having a forward operation. Because otherwise, if this is the problem, then you will not have a reverse operation too, right? So after this is I'll move the probe to the terminal 11 of the KM2, and for sure I'll have 24 volts. And then I'll move my probe to number 12 of KM2 again. Then I should be having 24 volts. If I don't have 24 volts, then my KM2 terminals 11 and 12 is having or is causing the trouble for our system, because this would be the reason why we don't have forward operation. But assuming that when I measured the when I measure the I'm sorry for that. Let me repeat it again. Assuming when I measured the when I measure the KM2, I'm having also 24 volts. So KM2 would be okay. So, but I'll still put KM2 terminal 11, 12 as the possible contacts why you're not having a forward operation. And if I will measure now, move my probe from after the S1 and I press S1 and I'm not having, or I'm having 24 volts, that only means that my S1 is in good condition. But if I don't have 24 volts after pressing S1, then for sure your start switch is not closing. That is why you're not having a forward operation onto your system. As simple as that. Now, let's assume that the timer is okay because it's a closing contact that would activate our KM1. Otherwise, if this one will not activate, then KT1 contact will not activate. Then our troubleshooting would be finished by changing on the KT1. Assuming that it is activating, so the next thing that we need to do is just to measure this line. So this only means, right, from the beginning, we're already having a flow of a good contact here, right? So this should give me another 24 volts. Otherwise, my KM1 will not activate. So the KM1 will also be the main reason. So the other reasons while you're not having forward operation would be the KT1 timer, either the KT1 itself or the contacts KT1, and lastly would be your KM1 main contactor itself. So for me, it is much faster for me to troubleshoot this one, because how would you know if your KT1 is activating or not, or this one is closing, if you're testing the system into a dead circuit? You switch off the main breaker, you don't know if your timer is counting or not. That is also one of the limitations when you are testing or doing a dead circuit troubleshooting. So I hope you're getting my point into why I'm saying that it is much faster to do a live circuit board when you are doing troubleshooting. It makes your troubleshooting easier, no? Team Anton, checking if there is summer without voltage. Rogelio Tampepe agrees, sir. Ayan. Thank you very much, guys, for watching to this another live. And I will try my best to do a daily live, most probably with the same time that we're having right now. And if ever I will miss it, and then for sure that I will be doing more like this onto the next days. So hoping that you are all in good health with your loved ones, and to those who are on board, safe sailing, sir, and happy holidays. So see you on my next video.